This is just demonstrating that the answer we had a minute ago in the other video was correct. We established that we have to have 23 goes to be 99.999% sure of hitting the target. In this question, P was 2/5. So if this is correct, we said the probability that X is less than or equal to 23, basically his first success has been up to and including his 23rd go, we have said that is going to be at least 99.999%. Again, to do this adding up of these probabilities, actually need to turn that round into a greater than, and the opposite of less than or equal to 23 is greater than or equal to 24. So if I'm turning it around and making everything the opposite, that will change around, and like before, that will change around. Changing that to a decimal, put 2 more noughts in. And greater than or equal to 24 will be the probability it's 24 plus the probability it's 25 plus the probability it's 26, and so on. Probability it's 24 is 23 failures followed by a success. This one over here would be 24 failures followed by a success. This one would be 25 failures followed by a success. And if I add those up, the formula I'm using is A over 1 minus R, where A is the first term, and on the bottom 1 minus R, R is the value 3/5 because that's what I'm getting an extra one each time. Just like before, they will cancel out and I'm left here with 3/5 to the power of 23. And if you work that out, 3/5 is 0.6, so 0.6 to the power of 23, I'm getting, that is 0.000000789 something. Now let's just see what happened if I had done 22 instead. If I had done 3/5 to the power of 22 instead, I would have got 0.000011316. And the whole question was about having this probability smaller than 0.00001. This one isn't smaller, 22 was not big enough, this one is smaller, 23 is big enough. I hope that's a little bit of a sort of explanation of why that answer really was the answer that we were looking for earlier in the question.